Hello, networking enthusiast. Welcome to the channel Gone. Today, I will tell you about ISIS in SONiC. As we know, in SONiC, all the ports are in layer 3 and all ports have assigned default IP addresses. So before starting of the video, I have removed all those default IP addresses and assigned those IP addresses that we have to use in our topology. Now, first of all, I will tell you something about ISIS. There are different terms in ISIS. The first term is NET. NET stands for Network Entity Title. Each router has its own NET. Here is the breakdown structure of NET, like AFI, Area ID, System ID, and the selector bit. So all the routers are in same area and level. Now I will go into router R1. Router R1. In router R1, first of all, I will show you the status of IP interfaces by using command show IP interfaces. Here we can see Ethernet 0 and 4 have assigned those IP addresses that we have to use in our topology. Now, let me show you something. In SONiC, the architecture of SONiC is designed in such a way that FRR is integrated on SONiC. For all L3 protocols, we have to use FRR commands. First, we have to go into BGP container and then start a daemon process which will run in the background. Now, I will show you this thing in router R1. First of all, I will go into Docker container, Docker BGP container. Docker exec it BGP bash. Oops, there is a mistake. cd/user/lib/frr ls. Here we can see there are lot of L3 daemons like RIP, ISIS, BRRP, and so on. Now I will start a daemon process which will run in the background. So daemon process has been started and it is running in the back. Since it is a redundant work, so before starting of the video, I have started this daemon on all routers R2, R3 and R4 as well. Now I will go into R2. Here we can see in R2 this daemon is running in the background. Since it is a redundant work, so I have already started before starting of the video. So we can see on R3 as well. Now I will show into R4. So everything is fine. Now again I will go into R1. Here I will exit out, Bitaish, configuration mode, router, ISIS, then Hamza. Now network entity title NET 49.0001, NET value of R1 49.0001, and then 11 tetra 1, and it is 3 times 1111.111.111.00. Tetra 1 is repeated 3 times. Okay. Now IS type level 1. Now I will exit out, exit. Now again I will go into configuration mode. Now I will go into interface, Ethernet 0, IP, router, ISIS, Hamza. Now ISIS, circuit type level 1. Now I will exit out and save configurations using write command. Oops. Again I will go into configuration mode, interface, Ethernet 0 and 4. Now I will repeat the same steps on Ethernet 4 as well. Ethernet 4, IP, router, ISIS, Hamza, ISIS, circuit type, level 1. Now exit and save configurations using write command. All the configurations are saved in isisd.conf file, which is present in the directory /etc/frr. Now I will go into R2 and repeat the same steps. Exit, btash, configuration mode, router, ISIS, Hamza. Now network entity title of R2 49.0.222.222.222.222.00. Now IS type level 1. Exit, because all the routers are in same area and level. Now I will go into interface Ethernet 0, IP router ISIS, Hamza, ISIS circuit type level 1. Now I will go into Ethernet 4 and repeat the same steps. IP router ISIS Hamza, ISIS circuit type level 1. Exit and write. Now again I will go into R3. Exit, dash, configuration mode, router ISIS Hamza, NAT value of R3 49.0.001.333.333.333 is .00. Now IS type level 1. Now exit. Now I will go into interface Ethernet 0, IP router ISIS Hamza, ISIS circuit type level 1. Now I will go into Ethernet 4. Now repeat the same steps. ISIS circuit type level 1. Exit, right. Now I will go into R4 and repeat the same steps. Exit, dash, configuration mode, router ISIS Hamza, NAT value of R4 49.0.001.444.444.444.00. Now IS type level 1. Exit. Now I will go into interface Ethernet 0, IP router ISIS Hamza. Now ISIS circuit type level 1. Now I will exit out. Oops. Now I will go into Ethernet 4 and repeat the same steps. ISIS circuit type level 1. Exit, right. So now I will go into R1. Now I will check the status of ISIS by using command show IP ISIS. Oops. Show ISIS. Show ISIS route. Here we can see everything is fine. Now show ISIS topology. Here we can see. Now show ISIS summary. Yes. Here we can see in ISIS summary, system ID is 11111 as we have assigned it to it. Now area name Hamza. As we can see here, entity value is this. The same we have assigned and the level 1. Now I will check the routing table. Show IP route. Here we can see I is written. What does it mean? I stands for ISIS routes. Here. So what does it mean? With R1 only two routes are attached directly, 10.0 and 11.0. These routes are advertised or entered in the routing table of R1 through ISIS protocol, 12.0 and 13.0. Now I will go into R3 and check the status of ISIS. Show ISIS topology. Yes, everything is fine. Show ISIS summary. Okay, yes, here everything is also fine. And show IP. Yes, we have ISIS routes. Now again I will go into R1. Now I will generate a ping request from R1 to R4, 192.168 and .13.2. .13.2. Yes, R1 is getting reply from R4, and we can see here the value of TTL is decremented by 1. What does it mean? It means that while getting the packets from R4, there is only a one router in the path or a hop in the path of the packet. That's why the value of TTL is decremented by 1. The default value is 64. Now I will go into R3 and will generate a ping request for R2. Ping 192.168.10.2. Yes, R3 is also getting reply from R2 and the TTL is decremented by 1. Now again I will go into R1. Now I will show you the configuration file of R1. Exit docker exit itbgp bash cd/etc/frr. As we can see here, there is a file isisd.com. In this file, all the configurations are saved. For all L3 protocols, all configurations file are present in the /etc/frr directory. Now I will cat it, cat isisd.com. As we can see here, configurations are present in this file. So thank you guys for watching my video. If you want more videos like this, kindly subscribe my channel.